Hello. Today's notes, we're talking about surface area. This is slightly different than the schedule I showed you. So we are doing surface area of all of the three-dimensional figures today, and then we are going to do volume of all of them next lesson. So let's remind ourselves what a prism is. A prism is a polyhedron with two congruent faces called the bases, and remember the bases are parallel. And then the other faces, those are called the lateral faces. So these are the non-base sides of a prism. And then our surface area is going to be the sum of the area of all of the faces. Sum of area of all the faces. All right, so an example. Find the surface area of a rectangular prism with a height of 2 centimeters, length of 5 centimeters, and width of 6 centimeters. So if we think about that, we kind of have this box, and you can unfold the box and cut it up into rectangular. And do you remember what this kind of drawing is called? It's back from chapter 1. That's called a net drawing. So basically, if we have a prism of any type, we can deconstruct it into the net and find the area of all the different pieces. So for this one, you're just going to find the area of all of the different sides. And we have 3 congruent rectangles here. So we have the top and bottom. So those are going to be our 5 by 6. So those are each 30 centimeters squared. Okay. And then we have our 6 by 2, which is going to be our sides, the left and right sides. And so those are going to be 12 centimeters squared. And then we have the front and the back, which are both going to be 5 by 2. So those are 10 centimeters squared. And since I have 2 of each of those, I have 2 times 30 plus 2 times 12 plus 2 times 10 is going to give me a total of 104 square centimeters. Okay, so that's my surface area. Okay, the next thing we want to talk about is we want to talk about regular prisms, we want to talk about right prisms versus oblique prisms. So in right prisms, my lateral sides are going to be perpendicular to my bases. Okay, and in my oblique prisms, Piper, quiet. And in my oblique prisms, that is not the case. It's kind of like rectangles versus non-right parallelograms, okay? So my oblique prisms are going to be like right prisms in a windstorm. All right, so here is a theorem. It says the surface area S of a right prism is 2 times the area of the base plus the perimeter of the base times the height. Okay, so you can use this theorem, or you can just calculate the area of all of the sides like we did in the first example and calculate the area that way. You don't necessarily need this theorem, but it is helpful. So let's talk about it. All right, so find the surface area of the right pentagonal prism. Okay, so our first goal is to find the area of the base. So if I have a pentagon, and we know it's regular, so that's helpful. I can think about it as 5 triangles, okay? So if I find the area of one of these triangles and multiply it by 5, that's going to be the area of my base. So area of base. So I'm going to B equals, all right, so let's find the area of one of those triangles. So if I look at that triangle, I know that this is 6 feet. And my base is 7.05 feet. So if I cut it in half to make myself a right triangle, then I can use good old Pythagorean theorem and do base times height. So that height here of this triangle, which is also called the apothem when you have a regular polygon, but we're not going to get into that. But just so you hear that word, that's also called the apothem when that triangle is part of a regular parallelogram or part of a regular polygon. Okay, so my little right triangle has 6 feet. Oops, I didn't mean to put an F. I meant to put a 6. And then 7.05 divided by 2 is 3.525. So if I do h squared plus 3.525 squared equals 6 squared. I'm going to get that h squared equals 36 minus, well, here, why don't I just put it like this? Oops, I meant to erase, not scratch out. Okay, so I get h squared equals 6 squared minus 3.525 squared, and then I take the square root of all of that. And I like to write it all out until my last step. So then my height is going to be approximately 4.86. And that's feet. Okay, so then the area of my triangle has base times height. So my base is 7.05 and the height we just found was 4.86. So then, oh man, I need a calculator. I did not do this ahead of time, which I should have. Okay, so 7.05 times 4.86 is 34.263. Okay, so that's just one of the triangles. And then I want to multiply it by 5. So the area of my base is going to be times 5. And I get 171.315 square feet. All right, so let's see here. So now we have the base for my formula. And we need the perimeter of the bottom. Okay, that's not going to be too hard. Okay, so my base, got it. Okay, so let's write down our formula again. So my formula for the surface area equals 2 times the area of the base, which we just got, plus the perimeter of the bottom times the height. Okay, so my height is 9, so that's my h, so I'll be able to plug that in here. Oops, I used h twice. I used it for the height of the triangle and the height of the prism. Oh well, that's okay. Okay. And then the perimeter of my base, well, if I have a side of 7.05, I can multiply that by 5 to find that the perimeter is going to be 35.25. Okay, so let's write that down. So perimeter equals 7.05 times 5, right? I'm finding the perimeter of that regular pentagon, and that is going to be 35.25. And then my height is 9, okay? And then my base we just found was this. So let's plug it all in. So my surface area is 2 times 171.315 plus 35.25 times the height of my prism is 9. And let's see here. Okay, so add 35.25 times 9. Plug it into my handy dandy calculator, and I get it is about 490 let's go with 57 square feet. Okay, so even though it's 3-dimensional, we're still only measuring area, so we're using units squared here. Okay, next definition. We're going to be talking about pyramids, and so there's 2 types of pyramids. There's lots of types of pyramids, but remember a pyramid, we have a polygon for the base, and then all of the sides are triangular, all my lateral sides, and those meet at a vertex at the top. So the height of my pyramid, as you can see in the second pyramid here, goes from the vertex to the base at a right angle. Okay, so that's what we call the height of the pyramid. And then the slant height is going to be when I go from the vertex to the base, the edge of the base, okay, along one of the sides. So kind of like if you were going to slide down from the top of the pyramid to the bottom, it would be the path where you would slide, okay. We are going to be talking about regular pyramids today, okay. So our bases are all going to be a regular polygon, and all of our sides, our lateral sides, are going to be congruent, okay. We're not going to deal with non-regular pyramids. You can do that later in your mathematical studies. Okay, so here's our theorem. Our theorem says the surface area S of a regular pyramid is the area of the base plus 1/2 times the perimeter of the base times the lateral slant height. Okay, So let's do an example. Find the surface area of the regular hexagonal pyramid. Okay, so let's get started here. So our formula, let's write it down, is surface area equals the area of the base plus 1/2 times the perimeter of the base times the height. Okay. Oh, good. They gave us the height of the triangle at the base. So if we have a hexagonal pyramid, so on the bottom here, my base, I can divide that base into 6 congruent triangles. Okay, so if I look at one of those triangles, it has a height of 5√3 and a base length of 10. So the area of that triangle is going to equal 10 times 5√3. And I have 6 of those, so my base area is going to equal 6 times 10 times 5√3. Okay, so let me plug that into my handy dandy calculator here. 6 times 10 times 5 times square root of 3 is 519.62. Okay, so I get 519.62 plus 1/2. And then the perimeter of the bottom, well, each side is 10 and there's 6 sides, so that's 60. And then my lateral height, they give it to us, is going to be 14. So then I plug all of that in together and I'm going to get that my answer, remember I rounded, so my answer is approximately 679.81, and my units here are square feet. Okay, our next shape that we're going to talk about is a cylinder. And cylinders are kind of nice because when I deconstruct a cylinder, well, so a cylinder is a prism where the top and the bottom, well, it's not really a prism because a prism uses polygons, but similar to a prism, but the top and the bottom, my bases are circular, and then I have just a single side that connects them. Okay, so when I draw the net of a cylinder, I have 2 congruent circles, and then the lateral area is going to be a rectangle. Okay. We are only talking about right cylinders. There are oblique cylinders as well, but to keep it easy, we're just talking about the right ones. Okay, so here is our theorem. Our theorem basically says the surface area of a right cylinder is going to equal 2 times the area of the base plus the circumference of the circle times the height of the cylinder. And since we know the area of the area of the bases, right? It's the area of a circle. So that gives me 2 pi r squared. So that's this piece, right? So the area of the base right here is this. And since there's 2 of them, that's where the 2 comes from. And the cool thing is when I think about the circumference of this circle right here, that circumference has to match the length of that triangle, okay? And then the height. So if I want to find the length of that triangle, area is base times height. Well, my base is going to be 2 pi r because that's the same as the circumference of the circle. So that's where that comes from, okay? So circumference is that 2 pi r from that circle, okay? And yeah, so that's the formula. So let's try an example. And this should say radius, typo there. Okay, find the height of the right cylinder shown, which has a surface area of 157.08 square meters. All right, so this is great because they give us the surface area and we want to find the height. Okay, what else do we have? We have the radius is 2.5 and that's it. That's all they give us. All right, so I'm going to use the one formula that has radius in it. So surface area equals 2 pi r squared plus 2 pi r times h. Okay, so we know the radius is 2.5 and the surface area is 157.87, so 157.08, not 87, excuse me, equals 2 pi, and then I'm going to plug in the r of 2.5 plus 2 pi times 2.5 times h. Okay, so when I go ahead, my next step, 157.08 equals 12.5 times pi. Just going to keep things in terms of pi to keep it easy for now. And then 2 times 2.5 is 5, so 5 pi times h. So then I'm going to subtract 12.5 pi from both sides. So then I have 157.08. Sorry, there's an extra decimal in there, but you get it. Minus 12.5 pi equals 5 pi divided by h. And then I'm going to divide both sides by 5 pi. And then when I plug this into my calculator, how I plug it into the calculator is I put parentheses around the entire numerator and around the entire denominator. Piper, hold on. I'm almost done. And then I plug that in, and the 5 and the pi are going to cancel, and I get that the height is going to be approximately 7.5, and my units here are meters. Okay, great. Our next shape is our cone, and I think this is our last shape of the day. And so for a cone, I can deconstruct it. So that basically I have a circle as the base, and then my lateral side meets at a single vertex. And if I deconstruct that, it is basically a sector of a circle. Okay, so that's how the area is found, and the surface area is by looking at that. So if you want to go through a more in-depth proof of how we get to the formula, I can show you that. But the formula is this. The surface area for a right cone is the base plus half of the circumference of the base times the lateral slant, okay? Or S equals pi r squared plus pi r times L. All right, so here's a picture of what all of those look like over here. So you can see R is the radius, L is my slant height, okay? So if we have a traffic cone pictured, and it can be approximated by a right cone with a radius of 5.7 inches and a height of 18 inches, approximate the lateral area. Okay, so what it means by lateral area, it means we're not including the base. Okay, so if I look at my formula here, so my formula is that the whole surface area is pi r squared plus pi r L, and for this one, I do not want to include that, okay, because that is the area of the base. So I am just looking for my lateral, Piper, quiet. So my lateral area for this one is just going to be pi r L. Okay, so let's figure this out. So if I have a radius of 4.7 inches and a height of 18 inches. Okay, so if I was to go from the top to the bottom on the inside of this, okay, so this is on the inside, that is going to be my 18 inches, and my radius is 5.7 inches, so that's my 5.7 there, and here's my 18, and I really, for my formula, I want L, which is the slant height, so I want this right here, so I'm looking for this, so that's L. And I can use good old Pythagoras, so 18 squared plus 5.7 squared is going to give me L squared. And so L is going to be approximately 18.9 inches. And so then when I plug it into my formula, so my lateral area is going to equal pi times my radius, which is 5.7. And then times my lateral height, which we just found was 18.9 inches, or my slant height, excuse me, which is approximately 338.4, and its area, and my units are inches, so inches squared. Okay, those are the notes for today. Sorry it was a little long. Go do your homework and let me know if you have questions.